Welcome to this video number 17 in my series of videos on Georg Cantor's 1895 and 1897 articles on the theory of aggregates and transfinite numbers. This section really starts to focus in on the numbers of the second number class, rather than parts or segments of it. We will see some of the basic arithmetical properties of a particular form of number from this class. The numbers dealt with in this section do not account for all of the numbers of the second number class. The remaining chapters of this article, however, gradually build a more complete picture of the numbers of this number class. I'll be going into quite considerable detail with this section and the sections which follow, and which will be covered in subsequent videos. Point 3 of this section follows from point 8 of section 14. The details of some of the results of page 175 will be shown on the screen. For the final case that's considered, we have as shown on the screen. The three cases just considered show that only the case where phi and psi are identical expressions will lead to the equality of phi and psi. This implies that the representation of phi in the form given in point 1 of this section is unique. For A of page 175, we see that since mu is less than lambda, then all terms of phi in the sum phi plus psi are followed on the right by at least one term of psi which is of greater degree than them. And so by 2, they may be omitted, giving phi plus psi equals psi. For B and C, we have the following. Point 5 is obtained by repeated application of B of page 175. The details of some of the results of page 176 will be shown on the screen. In relation to point 8 on page 177, we have as shown on the screen. That omega to the power of lambda times kappa plus 1 is equal to omega to the power of lambda plus 1 all multiplied by kappa follows from 5 of this section. Point 9 follows immediately from this result. Notice that in the resolution of phi of point 9, kappa tau is leftmost and the subscript descends as we move to the right until we reach kappa naught at the rightmost end. This is the reverse order in which the kappas appear in the form of phi in point 8, where the leftmost is kappa naught, and the subscript increases as we move to the right of the expression until we have kappa tau at the right-hand end of the expression. Of course, due to issues with commutativity of multiplication of ordinal numbers, then we cannot simply collect all of the kappa at one end of the expression in 9. In the form for phi given in 8, then we see that if mu tau is equal to 0 and kappa tau is greater than 0, then phi can be obtained from some other number by the first principle of generation. That is, by repeatedly adding 1 until phi is reached, and thus phi will be of the first kind in this case. In the case where mu tau is not equal to 0, then phi is not obtainable by the first principle of generation, but is obtainable by the second principle of generation. Thus, in this latter case, phi is a number of the second kind. Thank you for watching. If you found this video useful, then please hit the like button and subscribe to my channel. You can see more videos on various topics on my channel, and if you have any suggestions for topics for future videos, then please feel free to let me know and I'll try my best to put something together. Don't forget to hit that subscribe button and keep an eye out for new videos being uploaded to my channel.